Hello everyone. Today I'm going to discuss about a useful topic in digital communication, that is source coding technique. There are different types of source coding techniques. For example, we have Shannon-Fano coding, Huffman coding, etc. Today in this particular lecture I'm going to discuss about what is the meaning of source coding technique and how it applies to our daily life communication through our mobile phones or computers, and how these coding techniques are applied in our daily life communication. Okay, first let us see what is the meaning of source coding technique and how many types are there and how they are implemented. We will also see how they are implemented with some examples also. Now let us understand what is the meaning of source coding. Okay, let us see what is the meaning of source coding. For example, if you have a discrete memoryless source, so it is like a discrete source which emits or which sends some discrete symbols or sequence of symbols which form a message. Okay, for example, let us think like you are using a mobile phone or you are using a computer. Suppose if you want to send a message through WhatsApp or any messenger, so you are going to type some message, right? So how do you type message? For example, hi, how are you, with some name or symbols or special characters or whatever may be the symbol. So let us assume all these individual letters are symbols. Here the symbol may be a character, alphabet, a number, or special characters, whatever it may be. All these things are known as symbols in digital communication. Suppose if your discrete source emits a set of symbols like this, if you send these symbols in a sequence order, then it forms a message. So that particular message comes out from this discrete memoryless source, and then the source coding, how the source coding applies after this. So when this message is given to the source coding, then the source coding will assign a group of bits to each and every symbol in that particular message. Okay, for example, here there is a letter hi, H and I. So for each letter, that is H, it will assign some group of bits. It may be 2 bits or 3 bits or 4 bits, whatever it may be, depending on the type of coding we used here. Similarly for I, some group of bits. For H, some group of bits. For O, some group of bits. Even for space also, it will consider. Space is also one symbol. That is also, it will allocate some group of bits. So finally, the simple meaning of source coding technique is, it assigns a group of bits to each and every symbol that is coming out from this discrete memoryless source. Okay. So finally, it converts messages into sequence of bits. This is what we know generally. In daily life, digital every communication is a digital communication. So the messages or information is transferred in the form of bits, that is ones and zeros. So how can I imagine how these information is transferring in the form of bits? Means this is the method they are using in the communication, that is a source coding method. So this source coding will convert all these information or messages into these kind of group of bits. Okay, this information may be in terms of text or image or video also. Everything finally after source coding will convert into some group of bits. Okay, here discrete memory less source. What is the meaning of discrete memory less source? Means the symbol which is coming from this source, each and every symbol does not depend on the consequence of other symbols. So every symbol is independent. You can assume that. And now, what are the different methods of source coding technique? Generally, we have two categories. One is a fixed length coding and variable length coding. So what is the meaning of fixed length coding? Here the name indicates it is a fixed. So what is fixed here? Length of the code. What is the meaning of length of the code? Length of the code means if there are 3 bits are assigned for each symbol in that message, and for second symbol also 3 bits, and for third symbol also 3 bits. That means the number of bits assigned to each and every symbol is fixed, it is constant, and that is known as fixed length coding. Similarly, variable length coding means if the number of bits assigned to each and every symbol is varying depending on the probability of occurrence of the symbols. Suppose here in this case, the letter H comes 2 times. Okay, 2 times it is repeated, but the letter Y only comes 1 time. That means the probability of occurrence of H is more, so that it will assign less number of bits. Similarly, the probability of occurrence of Y, this symbol is less, so only it occurs once. So that means we'll assign more number of bits. That is the variation of assigning the bits to each and every symbol. So that is known as variable length coding. So if you use variable length coding, automatically you can clearly observe the number of bits, total number of bits assigned for this particular message is going to be less when compared to fixed length coding. So nowadays every digital transmission uses compression techniques. That means your data or image or video finally when you are downloading, automatically you can observe that the length or size is going to be reduced. For example, a 10 MB of your image, if you transfer through WhatsApp, automatically the size will be reduced, because automatically the WhatsApp software will apply some source coding technique as a compression technique. So automatic compression techniques will be applied so that the size will be reduced. Size reduced means the number of bits are going to be reduced because of using variable length coding. So here in this class we are going to understand what are the methods used for this variable length coding. The methods for variable length coding are known as Shannon-Fano coding and Huffman coding. So these two are the very fundamental and useful techniques which comes under source coding as a variable length coding. Okay. Now there is a procedure for each and every technique we need to apply. We need to follow some steps. So before going to understand Shannon-Fano or Huffman coding, first we'll see what are the source symbols that is coming from the discrete source, and how to observe the probability of occurrence of each source, and so on. So now let us see some simple representation here. For example, if we assume there is a discrete memory list source, so it emits some group of symbols. Suppose it will emit x1 as a symbol, x2, x3. What are x1, x2, x3? The letters. Instead of writing a general message, here I can represent like x1, x2, x3, and so on. So these are the set of symbols. So if from this message you can clearly observe that H is having probability is different when compared to Y. So because Y occurs only one time, H occurs 2 times. So that means probability of occurrence of each symbol is different. So let us represent the probability of occurrence of each symbol as P of x1, P of x2, P of x3, and so on. Okay. Here the symbol may be letters, numbers, or special characters. We already said that. Okay. So based on this probability of occurrence, or based on the probabilities of each symbols, we can easily apply the Shannon-Fano coding or Huffman coding. Okay. So this thing I already explained. The source coding means assigning some group of bits to each and every symbol that is coming from this discrete memory list source. Suppose it emits x1, so x1 will be assigned as some group of bits 101, so 3 bits. For x2, 4 bits are assigned. So that means it is a variable length coding, because x1 we are assigning 3 bits, x2 we are assigning 4 bits, different. If it is fixed, 3, 3, 3, 3 fixed, then this is known as fixed length coding. But what we are going to discuss is variable length coding. Under variable length coding, there are 2 types, Huffman coding and Shannon-Fano coding. So in this class, we are mainly focusing on Shannon-Fano coding. Okay. So what are the basic steps in this Shannon-Fano coding? The first step is, step 1 is list out the source symbols in the decreasing order of their probabilities. First I will read out these steps, then we will implement one by one. First, list out the source symbols in the decreasing order of their probabilities. So we need to list the symbols in the decreasing order of their probabilities. Second step is divide the list of source symbols into 2 groups of almost equiprobable groups. So when you read these statements, so you feel like some difficulty, but don't read these statements directly. So we'll implement while reading this each and every step. For example, let us implement the first step. What is this? List out the source symbols in the decreasing order of their probabilities. So we have a list of source symbols, suppose x1, x2, x3, and we have every probability of these source symbols. We need to arrange these symbols in the decreasing order of their probability. That means highest probability first, lowest probability next. Let us see an example. For example, a discrete memoryless source has 4 symbols. That means it is generating 4 symbols, x1, x2, x3, x4. We can assume like that. And having the probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 8. So 4 probabilities are also given. Apply Shannon-Fano coding and find the code words for all the symbols. Now let us implement this by using this procedure. Let us implement first step. First step is arranging the source symbols in the decreasing order of their probabilities. So here I am taking a probability column. In that, highest probability must be right first, and then next highest, and next highest. Okay. So here the symbols are not given with any name. So let us assume that they are x1, x2, x3, x4. Let us assume these are the 4 symbols, and one of the symbol is having highest probability, that is 1 by 2. So that we need to arrange the symbols in the decreasing order of their probabilities. So this is the symbols, this is the probability. Okay, there are different stages we need to apply it in order to get the final code. Okay, so finally from this Shannon-Fano coding, if you apply the Shannon-Fano coding, finally what we get means for each and every symbol we will get some group of bits, we will get some code. That means for x1 there will be a code like 101 or 010. We don't know how many number of bits it will assign depending on the probability. Okay, for x2 also will get some code, for x3 also will get some code, for x4 also will get some code. So let us see how we get. So this is the first step, arranging the symbols in the decreasing order of their probabilities. For example, if the symbols are given with some names like A, B, C, D, etc., then you should keep in mind that the symbol which is having highest probability, that must be represented on the top, and the symbol with the lowest probability, that must be represented on the bottom. If any probabilities are equal, you can represent either way. Okay, because they are same. Now let us implement the second step. Divide the list of source symbols into 2 groups of almost equiprobable groups. Okay, that means we need to divide the source symbols into 2 groups. Here how many source symbols are there? 4 symbols. We need to divide them into 2. So there are many possibilities of dividing. Okay, so we can divide x1 as one group, x2, x3, x4 as other group, or x1, x2 as one group, x3, x4 as another group. Similarly, these 3 are one group, the last one is other group. So we can also divide like these possibilities. But what is the rule here? What is the rule? Divide the list of symbols into 2 groups of almost equiprobable groups. That means each subgroup, if we add the probabilities, then when we compare the total probability of each group, they must be almost same. For example, let us apply this. Here, initially I want to divide these into 2 groups, x1, x2 as one group, and x3, x4 as another group. So let us see what will happen if we divide like this. Then we add the probabilities of these 2 subgroups. For example, if we add these 2, 1 by 2 plus 1 by 4, okay, that is 3 by 4. And what is the probability of these 2? 1 by 8 plus 1 by 8, that is 1 by 4. So this is 3 by 4, this is 1 by 4. So 3 by 4 is very high compared to 1 by 4. So this division is not matching according to our rule. Okay, so what is our rule? If we add the sum of the probabilities of each group, the sum of the probability must be almost equal. Now I am going to change the division, like x1 as only one group, the remaining 3 as another group. For example, this is one group and these 3 are another group. Now let us add the probability. So the sum of the probability in this group is 1 by 2, and when we add all these probabilities, what is the value? 1 by 4 plus 1 by 8 plus 1 by 8. This is 1 by 4 plus 1 by 4, that is 2 by 4, that is 1 by 2. So this is 1 by 2 the total sum is also 1 by 2. That means the two groups, we are divided that the two groups of having almost equal probability. This is 1 by 2, this is also 1 by 2. Like that only, you need to divide the symbols into two groups of having almost equiprobable in the subgroups. So the second step is over. Next, what is the third step? Assign 0 to the upper group elements and 1 to the lower group elements. So these are the bits 1 and 0. How 0 is assigned? 0 is assigned to upper group element. What is upper group element? This is assumed as upper group and this is assumed as lower group elements. So in the lower group elements we have 3 symbols. In the upper group elements we have 1 symbol. So for upper group we need to assign zeros, and for lower group we need to assign ones. Okay, that is the rule. Assign 0 to upper group elements and 1 to the lower group elements. So how do you assign? Like this. Okay, assign 0 to the upper group elements and 1 all ones to the lower group elements. That is the third step. Then what is the fourth step? So repeat step number 2 and 3. Again we need to repeat these two steps and each of the subgroup until the subgroup contains only one symbol. That means this process will be repeated. What is repeated? Again we need to divide the source symbols into two groups of having equal probability, almost equal probability. So first we divide like this, assign 0 to the upper group elements and 1 to the lower group elements. Again we need to divide this subgroups into again subgroup. For example, let us try to divide this into groups because it is only one element, so we cannot divide further. So that's over. So coming to this one. So we need to again divide these three symbols into two groups. How do you divide? Again the same rule. I am dividing this x2 as one group and x3, x4 as another group. So why only like this? You can try with another also. For example, if you divide x2, x3 as one group, x4 as another group, then if we add these two, that is 3 by 4 and this is 1 by 8. So this 3 by 4 is very high compared to 1. So that is the division is against our rule, because the sum of the probabilities of each subgroup almost must be equal. So I divide that x2 as one group, x3, x4 as another group. So what is the probability in this subgroup? That is 1 by 4. What is the probability in this subgroup? That is again 1 by 4. So almost equal. So again repeat the step number 3. That is assign 0 to upper group elements, 1 to lower group elements. So again assign 0 to upper group elements, 1 to lower group elements. Again repeat the process. So again we need to divide this into subgroups. Since it contains only one element, so we cannot divide. So here we have two elements. So divide this into two groups. Assign 0 to upper group element and 1 to lower group elements. So after the division is over, since it contains only one element in each group, so we cannot divide further. For example, in this group it contains more than one element, again we need to add another stage, stage 3, stage 4. So until each subgroup contains only one symbol, we keep on repeating these steps. So finally we have left with only subgroup with only one element, so we stopped that division process and also assigning the 0 to the upper group element and 1 to the lower group element. That's over. So finally, how to write the code? How to write the code for each symbol? So directly writing the code in this order is simple in the case of Shannon-Fano coding. For example, how to write a code for x2? So the code for x2 after implementation of Shannon-Fano coding is directly writing as the order of symbols, the order of ones and zeros assigned to this x2. Okay, so that means 1, 0 is the code for x2. Similarly, for x3, the code is 1, 1, 0. So it's a very simple, direct way of writing the code. So let us see what are the code for each symbols. For x1 it is 0, for x2 it is 1, 0, for x3 it is 1, 1, 0, for x4 it is 1, 1, 1. So this is very, very simple, right? So this is the way of applying Shannon-Fano coding for this source symbols, and what is the procedure of getting the final code words for each and every symbol. So this is very simple example. Okay, here in this example, a discrete memory source is sending 4 symbols if the probabilities are given. Okay, this is a very general case, general example. But if you want to apply this into practical case, then you need to assume these 4 symbols as one message. In that message, you can apply based on that message, you can apply Shannon-Fano coding also. We'll see that later. Similarly, we have another example. So a discrete memory source has 9 symbols. Here the number of symbols are more. 9 symbols with probabilities are given like this. Okay. Then we need to apply Shannon-Fano coding and find the code words for all the symbols, and also we need to calculate the coding efficiency. So here we have a formula for coding efficiency from the information theory in digital communication. So we can directly apply this formula. This is also we'll see here. Here the same procedure. First step is arrange the symbols in the decreasing order of their probabilities. That means the highest probable symbol must be right first. The lowest probable value must be put on the bottom. So this is the arrangement of symbols in the decreasing order of their probabilities. So the second step is divide these symbols into 2 groups of having almost equal probability. Suppose 0.49 is almost half of the one. So if you add all the remaining probabilities, that almost give you 0.4. So this you need to make some trial and errors. So you can take your calci and try to add all these symbols and make sure that each subgroup, the sum of the probabilities in each subgroup must be almost equal. Okay, you can try with this. If you divide x1, x2 as one group and x3 to x9 as another group, then you add these two and add all these probabilities, automatically this value will be very high compared to this one. So that's why that is not taken as a subgroup. Like that, this is one group and the remaining are other groups. So assign 0 to upper group and 1 to the lower group. Then in the next stage, again divide this subgroup into again 2 groups. Okay, based on the division that the sum of probabilities in each group must be almost same. Suppose if you add all these probabilities and if you add these 2 probabilities, the sum will be almost same. You can verify. Similarly, again divide the subgroup into 2 halves. Again this also into 2 halves. Assign 0 to the upper group, 1 to the lower group. Here also assign 0 to the upper group, 1 to the lower group. Again divide this group into 2 halves. This is upper one, this is lower one. Assign 0 to upper one, assign 1 to lower one. Again divide this group into 2 halves. This is one and this is second half. 0 to upper group, 1 to lower group, and so on. Finally at the end, this subgroup is divided into again 2 halves, 0 and 1. Okay. Since there is no further division because each subgroup contains only one element, you cannot divide further. So finally the code for each symbol we can write directly based on the sequence. So code for x1 is 1, code for x2 is 101, 100, code for x3 is 101, and so on like this. Okay, you can clearly observe that it is a variable length coding. That means for some of the symbols we are assigning less number of bits, and for some of the symbols we are assigning more number of bits. And also another observation is the least probable symbol is assigning with more number of bits, whereas the highest probable symbols we are assigning with less number of bits. That means, for example, in your name or in your message, if any character or any alphabet is repeating number of times, so that the probability is very high. For that case, the number of bits we can assign with very less, either 1 bit or 2 bits. Okay, because it is repeating, you can anyway recover at the receiving side. That's why it is very less number of bits are required for repeating modes. So this is the code word length, that is L of xi. So xi is symbols, probability of xi, p of xi is probabilities, L of xi is length of the code word. Length of the code word means number of bits. How many number of bits for x1? 1. How many number of bits for x2? 3. How many number of bits for x4? 4, and so on like. So based on this L of xi and P of xi, we have a formulas. Based on that, we can able to calculate first entropy, that is H. The entropy value, entropy is known as the average information. It is calculated as H. That is formula is sigma. That is the summation of P of xi into log of 1 by P of xi. So we know about P of xi, we know about summation. So substitute all these values. P of xi means this one. P of x1, P of x2, P of x3, and so on. There are 9 values. So all these 9 values must be added like this. For example, 0.49 P of x, 0.49 into logarithm of 1 by 0.49 plus 0.14 into log of 1 by 0.14, and so on. That addition must be done up to I equal to 1 to 9. Okay. So finally in your calc, we need to divide this into divided by log 2 base 2, because in your calc logarithm is not base 2 but it is base 10. So to convert that logarithm, we need to divide them into log 2 in your calcium only. Okay. So anyway, this is a calculations part. Anyway, we can do. And L, capital L is the length of the average code word length. So to calculate the average code word length, for example, for some symbols we are assigning 1 bit, for some symbols we are assigning 3 bits, and for some symbols we are assigning 6 bits. So what is on an average? What is the average code word length we are assigning to each symbol? If you want to calculate average number of bits, then there is a formula here, summation of P of xi into L of x. That means very simple, multiply these two. 0.49 into 1 plus 0.14 into 3 plus 0.14 into 3 plus 0.07 into 4 plus, and so on up to this. When you do like that, we will get some value in terms of bits, that is 2.38 bits. An example. Like that, if you calculate H and L, that is entropy and average code word length, then there is a formula for coding efficiency. The coding efficiency is represented with the letter N or eta. So percentage of coding efficiency is equal to H by L into 100. If you do calculate H separately and L separately, then you can divide and multiply it with 100, so that we'll get some percentage. So that means this percentage will indicate that how efficient your coding technique is. So in this example, the efficiency is 98.3%. That means the efficiency of the code is 98%. That means 98% efficiently we can able to encode the source symbols into bits. Okay. If the efficiency is good, then automatically your coding is also very good. Or the efficiency of the code is good. Okay. How can you say that without calculating this percentage? How can you say that this coding method is very useful method? Then the answer is, from that total number of bits, if you calculate all the total number of bits, the total number of bits for this particular source symbols are more, automatically that coding technique is not efficient. Because if any coding technique assigned with less number of bits for all the symbols, then that coding technique is efficient. If any coding method or a compression technique uses less number of bits or less size, automatically we can say that that is efficient. Or else, if we can calculate this value as a percentage of coding efficiency, based on that coding efficiency, you can able to calculate and observe how efficient the coding technique is applied. Okay. Now coming to the most interesting concept or example as how to convert your name or any message. For example, for interesting curiosity, you can take your name, your personal name. You can convert your name into encoded bits by using this Shannon-Fano coding method or Huffman coding technique. Anyway, I will explain Huffman coding technique in the next lecture. But today, after watching this, you can clearly understand what is the Shannon-Fano coding technique. Take your name, instead of your NAME, you can type your name. From that name, identify identify how many number of symbols are there in your name. How many number of symbols are there? For example, here how many number of symbols are there? N, A, M, E, 4 symbols are there. And let us assume N, A, M, E as x1, x2, x3, x4. Instead of writing x1, x2, x3, you can directly write N, A, M, E in this table. N, A, M, E. What is the probability of N? What is the probability of E and so on? How do you calculate this probability? Okay. Here probabilities are given in the problem, but in this example no probabilities are given, only your name. From the occurrence of each and every character in your name, you can able to calculate the probability. For example, 4 places are there. In these 4 places, N occurs only one time. So the probability of N, P of N is 1 by 4. Since A is also repeating only one time, so P of A is also 1 by 4, P of M 1 by 4, P of E also 1 by 4. Okay. For example, if your name is like encoded, if you take this is your name or some message, then how to calculate the probabilities of each and every symbols in this message? First of all, you need to identify how many number of symbols. You need to count how many number of distinct symbols. Okay, how many number of symbols are there? E, N, C, O, D, E. Again D repeated. So D must not count 2 times. So total how many number of symbols? 1, 2, 3, 4, 5 only. Since E is also repeated, only 5 symbols. Okay. So then what is the probability of each symbol? How to calculate this probability? Since E occurs 2 times and D also occurs 2 times, total how many places are there? 1, 2, 3, 4, 5, 6, 7. So by using combinations, you can easily calculate the probability. So 7 places E occurs 2 times. So probability of E, P of E is equal to 2 by 7. P of N is 1 by 7, 1 by 7, 1 by 7. D also, P of D also 2 by 7, since it is repeated. So anyway, I will explain this example very clearly in the next coming lecture, as we are going to explain about this Huffman coding. While we are explaining about this Huffman coding technique, I also explain about this concept based on Shannon-Fano coding as well as Huffman coding technique. But it is the knowledge from this lecture is enough to apply this Shannon-Fano coding technique for your name. And finally, your name is going to be converted into this kind of group verbs. How to convert? For example, here N, A, M, E, the probabilities are there. We are going to apply this method. Finally, for N, A, M, E, we will get some codes. And finally, how to write the sequence for your name? So based on the occurrence of each letters in your name, first write the code for N, write the code for A, write the code for M, write the code for E. So finally, that is the unique sequence for your name. And after the conversion of this code, the code must be uniquely decodable. Uniquely decodable means from this sequence of bits, if you convert back, that means these 4 bits must be N only. That must not match to A or M. Okay, that is the meaning of uniquely decodable. So anyway, all the sequences that is coming from Shannon-Fano coding or Huffman coding are automatically uniquely decodable. That is no problem, but you can verify. Okay, so this is what the analysis of Shannon-Fano coding as a source coding technique. So in the next coming lecture, we are going to discuss about Huffman coding, more examples on this interesting topic. Okay. So thank you.